Well, I'd like to introduce our speaker this evening, Professor Sir Brian Hoskins. He's a meteorologist who has spent a lifetime exploring and explaining how the atmosphere works, spanning both weather and climate. And he's written over 100 research papers, which are, in their turn, are brought in on many other references for other papers. He's active in his role of bending the political year, I think we ought to say, in that he's concerned about climate, and he was the first director of the Grantham Institute for Climate Change here at Imperial, and he's going to give a few words about that, about what that institute is doing. He's also professor of meteorology at Reading University, and is non-executive director of the Met Office, although I've never seen him give the weather forecast, but perhaps I missed it. He's a member of the Inter-governmental Panel on Climate Change, and he is a member of the Climate Change Committee advising the UK government on its policies. He's also a member of scientific and meteorological institutes both in China and in the United States, and has been awarded many prizes, medals, and citations around the world for his work. He was appointed Commander of the British Empire in '98 and was knighted in 2007 for his contribution to environmental science. He's also a Fellow of the Royal Society. What better speaker could we have to tell us about climate change? Will you welcome Sir Brian?
Well, thank you very much, Rod. That's a very nice introduction. And good evening, everyone. It's a pleasure to be here tonight to talk to you about climate change. But perhaps let me give a few words about the Grantham Institute first. The Grantham Institute started in 2008, and I was its first director, and did that role for 6 years, and I've been chair for the last 4 years. We've been on celebrating our 10th anniversary this year and just finished that. And lectures from Al Gore and Prince Rainier were part of that celebration. But the Grantham Institute does a number of things in Imperial. It sits between the departments as one of the global institutes of Imperial, and it acts as a focus for the research, enabling bigger research projects and people to meet there and do more research. It acts as a focus for the research in terms of the PhD students. There's a PhD program which has about 30 students a year, and they come to the Grantham Institute to do things together, and then they go out to the various departments around Imperial. And so it fulfills this object we have of producing people who are 5-star researchers, but able to talk to one another and to the outside world. And that's what we're doing. We have started with the business school a master's in climate and finance. And we've also then done a lot of trying to influence, as Rod has suggested. We try and influence politicians, what goes on in business, and what goes on in the public in general. So it's a very active place to be, sitting between the departments at Imperial. And I've really enjoyed it. Been at the University of Reading for many years. I am originally a mathematician, and as Rod suggested, I've spent using mathematics trying to understand how the atmosphere works in weather and climate. And I haven't written research papers about climate change, but I've been very involved in the climate change issue. In fact, I gave my first talk on climate change, public talk, in 1985 to the Clean Air Society in Scarborough. And in those days, there'd been panorama programs with icebergs coming up the Thames. Were we entering the next ice age? So the title I gave was Climate Change, Will We Freeze or Fry? And I came down on the side of frying was what we had to worry about. And that's what I'll be talking about tonight. So I'll give you a little bit of the science. As I go on, I tend to give rather less of the science because I think in general people have heard rather more about that. And as there aren't too many people who deny, apart from a certain Trump, but apart from that, there aren't many people in the world who say, well, this is rubbish. The question is, what do we do about it more? And so I'll spend a little bit of time on some of the science and what that's telling us, and then perhaps rather more time on some of the implications of that and how we're handling it. So is this going to work now? No, okay, I'll use this then. Right, so I don't think any talk on climate change can really start without giving a picture of a measurement of carbon dioxide in the atmosphere. Now, this was done in Hawaii, but carbon dioxide stays in the atmosphere so long that it's well mixed, and it doesn't really matter where around the world you measure it. It would be really rather similar. And this started in 1957. It's part of the thing that this is not a new problem. In fact, it had been discussed for a century before that. But in 1957, someone persuaded the US authorities to fund them to stay in Hawaii measuring carbon dioxide every day. So that's quite a brilliant proposal, that. So, and what we see here then, you see the red curve shows the annual cycle, which is associated with there being more vegetation in the northern hemisphere than the southern hemisphere, and the vegetation soaks up carbon dioxide in the spring and breathes it out in the autumn. So that's the annual cycle. But if you just smooth that out, then you see that curve going up there. And the units, you needn't worry about, but they're parts per million. But if you see the numbers there, it started at something below 320, and it's now somewhere near 410. And that is a very significant change. And we know that in pre-industrial times, you can, from all sorts of measurements, that the measurement was about 280. And if you go back in the last million years, it's gone between 180 in the middle of the glacial times, to about 280 in the warmer times, the interglacials. So it was going up and down on a timescale of 100,000 years. And then along came us, and since then it's gone from 280 up to 410, a 40% increase in that very short time. So we know this is due to us. There are all sorts of evidence that I won't go into, and there are a number of lines of evidence. This is due to us burning fossil fuels. So it's the amount there is going up. And we know also that carbon dioxide is a greenhouse gas, a very important greenhouse gas. And what that is, in fact, Tyndall, who was in the forerunner of Imperial College and also in the Royal Institution, in 1859 actually published a paper in which he showed that in the laboratory, if you took a gas like carbon dioxide, if you shone sunlight at it, those sorts of short wavelengths, it went straight through. But if you shone the infrared, the sort of heat at it, it was absorbed and then re-radiated. So it's been known for 100 years, even before this record started here, that these greenhouse gases around the Earth, then they let the solar radiation through, but they absorb the heat that's given off by the Earth and re-radiate it where it's colder. So the loss to space is smaller because it's from a very cold region. So they're a blanket around the Earth. And without them, the Earth would be a frozen ball. So these greenhouse gases are really great, really good news. However, like a lot of things, too much of a good thing is actually not so good. So we've added a lot of this greenhouse gas here. The number one greenhouse gas, by the way, is water vapor. However, if you put water vapor in the atmosphere, if we put extra water vapor in, it cycles round within a few days, and certainly by a week, essentially it's cycling through. The thing about carbon dioxide, once you've got it in the atmosphere, it stays there for centuries and essentially accumulates. So, let's see if this is working now. No, it doesn't want to work, so no, I'll do it by hand. So, I've said there, it just accumulates on the century time scale. So in terms of our timescales of our activity, it's when you drive down the street, the CO2 you're producing will change the CO2 in the atmosphere for the next 1,000 years. Okay, so it's not a short timescale problem. It's accumulating all we're doing to it. And as it accumulates, we know it is warming the Earth more. The only question is how much and what are the other impacts. It isn't just carbon dioxide. There's other greenhouse gases, principally methane, nitrous oxide, fluorocarbons, and a few others. And together, those add about 20% more to the effect than the carbon dioxide. But the number one thing is carbon dioxide from fossil fuel burning. So is the Earth warming? Well, there's been people around the Earth measuring temperatures for a long time. A lot of them were from the Church of England at one time. They seem to have enough time to go out and measure temperatures and enough interest to do so. But they're around the world. There are all sorts of measurements. And people have put them together. And there's an uncertainty in the initial period, but as you go through, then that uncertainty disappears. And like all these geophysical things, there's ups and downs associated with the record. But I don't think you need a PhD in meteorology to think that the climate is actually warming when you see this. So this is globally average temperature here. Is this switched off, Rod? I don't know. Maybe that's what's happened. I'll give that to my technician here who will just... so, you're brilliant. Well done. Okay. Yep. Okay. Thank you. So you can see, certainly since there were some ups and downs here, quite warm during the 40s here, and this was the time people were wondering, was the temperature cooling through here? But no, since 1970, we've seen this upward movement here. And let's see, these very warm years are years when there's an El Nino, if you've heard about that, which is something happening in the Pacific Ocean. And back here, there were those who said, oh, the climate stopped warming. However, I think you only need to look on a rather longer time scale, and there certainly is warming in the system. About 0.2 degrees per decade. That's the warming rate here. And this year is going to be somewhere about on the green line. It looks like we're getting another El Nino for next year, so we can expect that this will be way up again for 2019. That would be my guess. Or if I'm going to give a Met Office thing, I'd say that's my forecast. Okay, so the climate is warming, right? So let's see if this button works now. Yes, it does. And we call it global warming. That's talking about the globally average temperature. But you can see if you look at this up here, which is over the 20th century, basically, that almost everywhere has warmed. And over land, almost everywhere has warmed by at least a degree, and far more in the northern continents here. And there's lots of other things go with this, but I won't go into detail. I'm just showing two here. One is sea level rise. Now, everyone thinks about glaciers melting. Well, they don't add too much. And getting a little bit more out of Greenland, that's getting increasingly important. But the main contributor to this up till now is actually the expansion of the ocean. As you get the warming ocean, water expands just a little, but if you've got 4 kilometers of ocean, it's only got to expand a little for actually to forget the sea level rising. And it's rising somewhere around 3 or more recently, perhaps 4 millimeters per year. That's 30 centimeters per 100 years, 40 centimeters per 100 years. So that's the rate of sea level rise, and the sea level's gone up about 20 centimeters. So if you take something like Sandy, the Hurricane Sandy hitting New York, there's always a discussion about how much was climate change involved in that. The biggest impact is probably that the sea level is 20 centimeters higher. So if you get a surge, that 20 centimeters is enough to make the damage so much greater. And in the UK, we're still rebounding from the last ice age as well. So Scotland's going up and southeast of England's going down. So the sea level rise is rather greater in the southeast of England than it is in Scotland. And there's changes around the world as well. The picture on the right then is the Arctic sea ice area. So sea ice grows all through the winter. reaches a maximum in March in the Arctic region, and then in the summer it decays and reaches a minimum in September. And this is the area of the sea ice minimum in September. And that is 8, and that's 4 in some units. So this isn't a small change, it's a big change of going down like this. And again, there's lots of ups and downs. Some people said, oh, the sea ice is going to be gone in a couple of years here, but it's come back to the same sort of line. But that trend line corresponds to Arctic sea ice disappearing somewhere in the middle of this century, in September, maybe 2050 or so. It will grow again in the winter, but it won't be as big and it won't be as thick as it was. And there's all sorts of other things going on with this. But if I'm going to proceed to some of the other things, I better just speak about some of the extremes that we've had as well. And I thought I'd give, while you can still remember the summer of 2018, a comparison with what some of us still remember, and I think quite a few in this audience might, the summer of 1976. And they were just about equally warm in the UK, both lovely. And I've shown pictures for June here. But what has been shown here, I didn't produce these, someone else did, but is actually to take the same background, the average temperature through the 1950 to 80, so that 30-year period, and look at the anomaly of 1976 from that. And you can see the UK very warm there, but a lot of blue around areas that were colder. Whereas this summer, yes, the UK is here, but almost everywhere is so much warmer than it was, that compared with the background, we're just not that much warmer. You might have heard on the news, I think yesterday or today, the Met Office saying that a summer like this one we've just had is now the sort of thing we should expect every 1 in 8 years. Whereas back in 1976, that was a sort of 1 in 200 year or 300 year event. So it's just become that much more likely. And by the middle of the century, the rate we're going, then it will be the sort of average summer. And that's the way we're going. So, and I thought I'd mention other things going wrong with that associated with precipitation. So we've had some record rainfalls around there. I won't go in detail. You might remember some of these wet events. And I've mentioned some from around the world, some wet and some very dry. There's been quite a discussion of how much the drought in the Middle East, in particular in Syria, was actually part of the stage for the problems in Syria. It's always mixed with the societal response to what happens, how much help there is from governments or whatever. But the background to many things in history, many events, has actually been a record, a poor harvest or whatever. So many things to do with rainfall. And would we expect that? Well, yes, we would. A warmer atmosphere can hold more water. So if it's 6 degrees warmer, then it can hold 50% more water in the atmosphere. So the same rainstorm, if it's 6 degrees warmer, you would expect to be 50% more rainfall coming out of it. So heavy rainfall events are what we expect, and it's what's been observed around the world. Not that you'll necessarily get more rainfall in the year, but when it rains, it's going to rain harder. And another thing you'd expect is tropical cyclones being stronger. Not everyone, but there is the possibility, because the fuel for a tropical cyclone is the warm ocean, the warmth in the ocean. And with the ocean warming, there is more fuel available to the tropical cyclone. And there's been a whole number of record tropical cyclones during this period. I mentioned Sandy before, but other ones. The 2017 one in the Atlantic was just amazing, with the tropical cyclones queuing up to hit the West Indies and Haiti, etc. So there's lots of things going on there. Now, thinking about the future, the way we approach this is through models that are evaluated in their performance in terms of the past. They're based on Newton's laws of motion, the equations of thermodynamics. They are developments originally from weather forecast models, but with modeling the ocean as well and modeling processes that aren't needed in weather forecasting. And they're not perfect, but they're a lot better than hanging up with your seaweed, and they really are well tested. So this is actually from the IPCC. I'll mention the IPCC a few times. It's the Inter-governmental Panel on Climate Change, and that's the group around the world that is asked by the UN to, the scientists asked to analyze and diagnose and put together all this scientific information that's been produced in the previous periods and then hand it to the politicians, to the countries of the world. So this is taking all the models and saying, well, if we go on emitting carbon dioxide and other greenhouse gases like we've been doing, then what's it going to be like at the end of the century? So this is looking over the 21st century, how might the temperature change? Well, globally, the temperature might change by about 4 degrees. But if you look locally, then we're seeing more structure than that. Almost everywhere over the land, the temperature will change by more than 4 degrees. That's because the ocean has a high thermal capacity. It takes a lot of heat to warm up the ocean, whereas the land warms up much quicker. So if you take the tropics, this picture here says you take the tropical countries, you take pre-monsoon India, where it's already 45 degrees, and you add 5 degrees on, so it becomes 50. And this is taking the tropical countries to a climate that's never been experienced before on Earth, or not for many millions of years. And so that's quite dramatic for them. And in the higher latitudes, you can see the dark colors, and that's a change of about 10 degrees. And in winter, it's more. So we're thinking of something of the order of 12, 15 degrees in the northern bits. So you can imagine what happens to the permafrost if you start warming it up by 12 or 15 degrees. It's not going to be very perma, I tell you. So there's big things there in terms of just changes of temperature. But if you look at this, then the temperature contrasts change. Now, weather depends on temperature contrasts. And so the weather would be different as well. It's not just, it's the same weather, but it's warmer. The weather is different in this situation here. So it's a different world we're entering then if we go that way. So I'm showing this thermometer here, which is taken from a Royal Society report that was launched in Parliament 3 weeks ago. I chaired the group to produce it, and I have a few copies if people are interested. But it was originally taking a summary, producing a 2-page summary of the recent IPCC report, which I'll mention later on, and then saying what are the implications for the UK. But if I take you up this thermometer then, so this is the pre-industrial temperature, and that's where we are today, and increasing at about 0.2 degrees per decade. Now on this side here, you see UNFCCC, that's the United Nations Framework Convention on Climate Change. And that's the UN getting together the groups of countries, all the countries of the world, to discuss what they're going to do about climate change. And they've been meeting since 1992. So that's the international body to actually try and get the things to happen on climate change. And over the years, they've decided that, well, we should try and stop the temperature changing by more than 2 degrees. And above there, they describe this as dangerous, but and it's never been as if 1.9 is safe and 2.1 is disastrous. It's a sort of more continuous thing than that. But anyway, that was defined as dangerous climate change. And in the UK, this is what we took for our Climate Change Act that I'll talk about later on as being the target that we would base that on. That's where we're headed if we keep going like we're doing at present for the end of the century and still going up. So we're here now, we're on our way to there, and we'll reach there if we don't do anything. So, but we have had various meetings of this UNFCCC. There was Copenhagen years ago, which you might have heard about, where there was great hopes. I went there, and our hopes were all dashed because the countries of the world could not agree. And then there was Paris in 2015, rising from the ashes of Copenhagen. And in Paris, the countries of the world decided that this 2 degrees was really an outer limit, and we should be staying well below that. And in fact, we should aspire to keeping the temperature rise to 1.5 degrees. So I'll say more about that in a minute. So this is the aspiration in Paris. And the other part of Paris Agreement was the countries of the world, instead of being told what to do, were asked, what would you do voluntarily? And if you add up all their voluntary contributions, then that would limit the temperature rise to about 3 degrees. So at the moment, that's what they've promised voluntarily. And part of the discussions that are going on in Poland now is, can we actually get them to have, first, obey the rules to get there, and secondly, to actually say, well, could you do more than that? Voluntarily, would you commit to doing more than that, and getting some peer pressure? So we've got what's going on in Poland now, and late next year somewhere else will be to try and get that down to more in this region here. So that's taking you up the thermometer on one side and down on the other side. So just some of the impacts of climate change. That recent Inter-governmental Panel on Climate Change report on 1.5 degrees, you may remember that was launched in October with quite a lot of publicity. And one part of that, they were very much comparing 1.5 to 2 degrees. And here we have a little of what's often called a burning embers diagram. This is the pre-industrial temperature, and this is 0, and then 1 degree is where we are now. 1.5 and 2 degrees we've discussed, so the warming. And where you see colors like yellow, it means it's quite a moderate risk. Where it's turned red, it's a high risk, and a deep color, it's very high risk. And so these are a couple of some 5 impacts that I'm going to highlight for you as you go up this thermometer here. And this is what they called unique and threatened systems. If you take the corals of the world in the tropical oceans, the Great Barrier Reef, etc., it's already in big trouble. And really, as this thermometer, that's the yellow here, and if we go up to 1.5 degrees, we will lose most of those warm water corals. And there's other species, maybe in the Arctic region, which are very much threatened by this. So this is this change through here, and we are looking at major extinctions of species as we go up through that thermometer there. Extreme weather events, well, you're hearing more of those around the world. I've highlighted some, and so we're getting into the moderate to high in there, and as we go up there, then the extreme weather events will increase. And let me just move across here actually to this last one here. Large-scale singular events, big things happening. So there is some trigger point for the Greenland ice sheet to melt irreversibly. It might take 1,000 years to do it, but we don't know where that trigger point is, but it might be around 3 degrees, perhaps. We don't know where that is. But even if you kept the climate at that temperature, then Greenland would go on melting. There's about 6 to 7 meters of sea level in Greenland. And so that would be rather significant for us. There's increasing concern over the Antarctic ice sheet as well. And that's usually been West Antarctic ice sheet, where again, it's rather different from Greenland. It's more the slumping of these ice sheets, which are not grounded on solid continent. They're often grounded on the ocean underneath, and then a few islands. And the stability of those ice sheets is not well understood, but there is expected to be some threshold on those. And in Imperial, we have people looking at aspects of the East Antarctic ice sheet, where again there's evidence that in the last interglacial period, then some of those slumped. Now, in the last interglacial period, which is 120,000 years ago, when it was just about as warm as today, or maybe slightly higher, but certainly not more than a degree higher, the sea level was 7 meters higher. So there's every indication that somewhere around these temperatures above here, we are looking at sea level, which will not change by 7 meters over the next century. It might change by 1 meter or perhaps 2 if we're unlucky. but over the many centuries, we would be looking at committing the world to a 7-meter sea level rise. So there's other big things to talk about, but I think sea level rise is enough for that. So I don't want to depress you too much, so we'll keep going. What can we do about it? Well, there's one solution here, which I used to call the George Bush solution, but that's perhaps a bit dated now. But we're doing one thing to the climate system, the younger George Bush. We're doing one thing to the climate system. We've got this belt around the Earth that we're making more of a thermal blanket that allows the solar radiation through, but stops the heat escaping. So why don't we stop some of that solar radiation? And that's the basis of this idea here. So one would be to put umbrellas in space, so you stop some of the sun's energy coming down. Or you put particles into the high atmosphere and you get something like a beautiful sunset. It's the sort of thing that volcanoes do, but you have to keep doing it, putting particles into the stratosphere, and they intercept some of the radiation up here, so I scatter the radiation up here. There's attempts. Some people think you can make clouds brighter to reflect the solar radiation, or make the surface of the Earth a bit whiter to reflect more solar radiation. The only one of these that is in any way practical is probably this putting particles into the stratosphere. And some people are considering that. If you did that in a big way, you might be able to counter a proportion of the warming that we're doing through our carbon dioxide, but the climate would still change, because the distribution over the Earth would, and in time, would be different. So it would, and for instance, one thing is expected the rainfall over the Earth would decrease. I think if you can't get the countries of the world to agree to mitigate climate change, you certainly couldn't get the countries of the world to agree to do this. So it's not the solution I think we should be looking for. Now, this recent IPCC report talked about how we should really limit the temperature to 2 or even 1.5 degrees. So this is how we've been emitting carbon dioxide in the recent period, up to there. So that's where we are today. And this is what they said we have to do in the world if we're going to limit the temperature to 1.5 to 2 degrees. So it has to come down to net zero. So if you emit anything, you have to take it out of the atmosphere, and it has to do that by around 2050, the middle of the century. It may be a little bit before for 1.5 degrees, or a little bit afterwards for 2 degrees. But it's that sort of thing. We should be looking for net zero carbon dioxide. Now that's a staggering change, and one of the things I'll be discussing now is it possible? The other aspect, just to say, is it's not just carbon dioxide. So we should be looking to reduce all the greenhouse gases to as low a level as possible. But the big one, of course, is the carbon dioxide. So this is another picture like this, which shows the past emissions of greenhouse gases and the rate we're going up here. And then this is where we should be heading. This is 2030, if we're going to 1.5 or 2 degrees. So it's like the previous picture on the way down to zero, but this is the more recent period. And this is where those voluntary contributions the countries have agreed to would actually lead us. So they're taking us some of the way down, but there's a lot more needs to be done. Now, you may have heard in the news, it's one of the difficulties of preparing a talk like this, it's happening every day. And yesterday, there was a paper released which actually talked about our emissions of carbon dioxide in the last few years. And there was great hope because a few years they'd actually just about stabilized. But unfortunately, the last year, they've started on the up again, and we're still in this area here. So and the next slide is actually to show, well, who's doing what. This shows all the years from 2000 to 2017, and it shows the emissions of carbon dioxide from fossil fuels. And this is the global one. You can see it was almost level, and then it started to go up again. And if we look at Europe, then it started going down. And if we even if we look at the USA, despite anything the president says, it is actually going down. China, everyone says China's the problem. Well, China has actually made an amazing change, given that change of slope there, to a level, certainly not started on the way down, but stopped on the way up there. And India is actually increasing at a rapid rate now. And this is the rest of the world. So you can see that in the developed world, there is some decrease. The UK is decreasing about double that rate. So it is possible, however, there's certainly a lot to be done still. So it is a transformation we're talking about if we're actually going to make the changes like this. It's not just something where one tinkers at the edges. It is living things and doing things differently. The number one thing always is to actually use the energy we have in a more miserly fashion, not waste it. And that's the first one, and maybe this is to energy efficiency and lifestyle changes. But we are looking for what the IPCC described as both rapid and unprecedented changes in energy, land use, urban development. Cities have to be designed differently. Transport has to change rapidly. The whole infrastructure and industrial systems have to take on a change. The sort of change they might have done on a time scale, maybe from here to 2100, has to be done in the next 30 years instead. So we're looking at doing what we would have done, but doing it faster. And some of those emissions may be awfully difficult to squeeze out from agriculture, industry, heavy industry, and aviation, etc. There are better ways of doing it. I see you're going to have a talk about electric aircraft. Well, that's maybe one way, but and maybe negative CO2 is going to be required, i.e. taking CO2 out of the atmosphere. It's much easier to stop it getting there, but can you get it out? And there's been a lot of discussion recently that this is a transition, but it's got to be a just transition. You can't tell Poland, right, you've got to close your coal industry without helping them to actually have an alternative. I mean, it's what happened to our coal industry in the UK. It was closed down in one region with no alternative. So the transition, both in countries and regions, has got to be helped by everyone to make it a just transition. So the technology, luckily, has come to our rescue in a big way. When we set the targets in the UK in 2008, we didn't really know just how the technology was going to improve. I've just shown a few examples here, but solar potential photovoltaics, it's just been an amazing drop. And this is actually, I should update this, but now in many countries of the world, solar power is actually the cheapest form, even compared with local coal. So it is amazing change that's happened over that period. Wind power as well. Wind power in the UK on land is our cheapest form of energy, electricity. Unfortunately, in England, we've ruled that out, but in Scotland, they certainly haven't. And wind power on the ocean there is an amazing resource that the UK has there. We are essentially the leaders in world resource of wind, and we also have the technologies associated with the North Sea. And so there's an industry knocking on our door there to be world leaders. The electric vehicle, which used to be a sort of gleam in someone's eye, and the only thought was a Tesla, within a couple of years, it's going to be the routine car that will be available to you. In fact, if the car industry didn't have such an investment in the petrol and diesel engine, they'd be there now in a big way. But they're trying to sell the others before the electric one comes on board. But essentially, this is going to sweep the board. Now, what we have to worry about is not the Chinese producing all this CO2. The Chinese are going to be the leaders in all these technologies. They already are in solar PV, in wind, and they're developing their domestic car industry as an electric industry. And this is going to be a real fight between the West and China and India coming up to see who is going to be the leaders in the technologies that the world needs. And it's just that sort of competition which will produce that transition, enable that transition to occur. We know all the technologies now, they will only improve as they're tried. Remember the mobile phone when it started. I mean, it's just an amazing transition. We've had that transition with a mobile phone, and it's happening with all these other things as well. Batteries are improving at an amazing rate. And of course, an intermittent thing like wind and solar needs those batteries in a big way. And it can fit in with cars. Cars can be part of our storage of electricity, which is then returned to the grid. And there's all sorts of interesting things that can be done here. I should say Imperial College is very much in the vanguard of all this, and the Imperial West is hoped will be a hive of this high-tech, this green high-tech that's required. Now, I talked about taking carbon dioxide out of the air, seeing the clock ticking by. I'm going to go through this a little quicker than I should perhaps. But there are various techniques for doing this. And if you're interested, there's a Royal Society report, which you'll be able to find on the web, which is Greenhouse Gas Removal, its title. So you can do this by helping the biosphere to take more carbon dioxide out of the atmosphere. So planting more trees. The UK could do with more trees. We're the lowest in Europe, I think, in terms of our tree area. And there are big plans to do that. Using wood in building, why not? And that stores it. And how we look after our land in various ways can soak up more carbon dioxide. We can use, we can put silicate on land to help absorb carbon dioxide, which is what happens on a very long time scale in terms of the rocks and the weathering. But we could actually absorb more carbon dioxide in that way. Or we can use a bit of high tech, and we maybe grow crops that are there for burning to gain the energy. We capture the CO2 as it escapes, and then we put it underground. So that way you take carbon dioxide out of the air and you get the energy. Or direct air capture. Maybe in the Sahara Desert with almost limitless solar power, you could then capture that carbon dioxide from the air and put it underground. So there's all sorts of things you could do. As I said, I just mentioned we should think of this in the climate change always in the wider context. A growing world population, urbanization, people moving to the cities, a changing diet, unfortunately not changing in the way that would be helpful to the climate or health. Both health and climate say, do not come to the meat diet of the West, which is increasing, go the other direction. There's many diseases in the Far East, particularly cancers, that were almost unknown before they started changing to a Western diet. And so there's increasing demand for food, water, energy. And then there's all the other global environmental changes. And there's the UN's Sustainability Development Goals. And climate change action is one of those. But actually, climate and stopping or mitigating the amount of climate change links with many of these in terms of poverty, particularly in the developing world. You've seen that the changes in the tropics will be the ones that will be almost most damaging. And so the countries trying to develop in the poorer parts of the world are the ones that will be hit by climate change. And so we have to deal with these problems together: hunger, growing food, health. We can deal with air quality and climate issues at the same time in terms of reducing fossil fuels, etc. And many of the other ones, it's a very strong linkage with climate change, and we should try and get solutions to the climate change problem that also provide solutions to the other problems that are faced in the world. I wanted to spend a couple of minutes, and I'm going to make it a couple of minutes, talking about the UK and what we're doing. Now, the Climate Change Act in 2008 is something that we can be really proud of. It's the first such legal obligation that the country put on itself in the world. And this was agreed in Parliament in 2008, and it sounds almost a dream now. 453 MPs voted for it, 5 voted against. You know, this was the days when we actually could get some agreement on sensible and forward-looking action. What it did was commit the UK, to an 80% reduction in our emissions by 2050. Now, I was on the group that helped give that target, and I won't go through it now, but basically it was saying, how could the world keep it to 2 degrees, this global temperature rise, and then every citizen of the world being allowed the same amount of CO2 per person per year. Part of that equity, then we would have to reduce our emissions by 80%. And we didn't just come up with a number, we knew how that could be done. We gave the ways this could be done. But it's not just a 2050 target. This act was so well designed. It was actually, the politicians, if it was just a 2050 target, they say, all right, we can forget that now, that's someone else's problem later on. But there's actually a succession of 5-year target budgets there. And they were set from 2010 onwards. So they're already set up to 2030, those 5-year carbon budgets. And the government of the day is required by law to be going towards those targets, both the present ones and putting in place what is needed for the future ones. So that's, and they established this climate change committee, which was what I was on. So this was where we were in 2006. And this is where we got to be in 2050. And these are all sectors here. This is electricity generation, domestic transport, etc. And the way to tackle this that we recommended is first to decarbonize the electricity generation. And we know how to do that using a lot of wind, solar, maybe some nuclear, and get rid of the coal first. And if we leave gas in, then we have to capture the carbon from it. And once you've decarbonized the electricity supply, you can then use that in domestic transport, the electric vehicle. But of course, you can't wait till it's been decarbonized. You have to start introducing electric vehicles now, and so that they become the whole fleet. And you can use electricity and heat, etc. So this is well possible to do. We know how to do it, and it can be done. So what progress are we making? Well, pretty good, really. That's GDP in the UK, and that's our carbon emissions, our greenhouse gas emissions. So they've just gone down 40% as the GDP has gone up 70%. We were the first country in the world to make those two go apart. And a lot of that, we'll see, is from electricity generation. But that's the good news. As I say, it's not so good when you look across the sectors. If you look at the recent changes in the last 5 years, then in the power sector, there's been a huge reduction in the emissions and quite a lot in our dealing with waste. However, if you look at most of the rest of these, the progress is negligible. We're still building houses, even new houses that leak like a sieve. They wouldn't go on the scale in Sweden, yet we still allow them to be built. You know, so we're making almost zero progress. And again, in transport, we have all these electric vehicles. Even the petrol engine is a lot more efficient than it used to be. However, we don't have the policies that are getting people going to the choices that should be made. The vehicles are getting bigger, the engines are getting bigger, and there's still the electric vehicle costs a bit more, and yet the advantages of tax loss are actually being taken away. So if the policies were there, this could actually be way down here, but it's the policies missing at the moment. And again, in buildings, retrofitting old buildings is difficult, but doing it to build new buildings is easy. And I mean, it may put 1,000 or 2 onto the cost of the house, not much more. So how are we doing? Well, this is how we've been doing here. These are the 5-year targets, and you can see them set out to 2030 here. And this is where we've been going and meeting these fairly easily. But the policies we have are just taking us here at the moment, whereas we should be somewhere down here. And certainly if we're headed towards the zero carbon by 2050, we've got to be somewhere down in this thing here. We know how to do it, but we need the policies to get there. The eye has been taken off the ball at the moment. Maybe there's something called Brexit rather taking over at the moment. But it doesn't need too much to get back, and we can do that. So we actually we told the government in our last report, by the way, I'm off the committee now, I've had my 10 years, but there's lots of low-cost things to do. Stop chopping and changing policy. It might be the same in various areas. You've got to actually have regulation and enforcement if you're going to make things happen. Act now for the long term. That could be said in various areas, but it certainly would be said here. So this is the basis of our targets at the moment. And this is what the targets have to be, something like this. So the report I chaired for the Royal Society the other day said we should be aiming for this 2050 zero. And what we need to do is tighten up, particularly in this bits around here. But the main thing is we have to get back on course from where we were. And then we can get down to these. So that's our current targets. So this is a challenge to business. Mark Carney has actually said to big businesses, are you resilient to these climate change? Have you factored this in? How much may you be dealing with these businesses that might be lost, become white elephants? Because if we really follow these lines, is that resource that you have underground really going to be so much value in 20 years' time? There's big questions there. So there's risks for companies, or maybe if you've a supermarket, do you know if your food chain is actually going to be robust under this? Of course, businesses are also under this divestment threat, which is people saying, well, I want my money to be going to what the future should be, and companies being threatened with this. But then this shouldn't be a threat. What should happen to a Shell, a BP, Exxon, whatever, is they should be the leaders in this transition, this transformation, and should be taking on board the new technologies that will be required. So there's a major opportunity, as I tried to say just now, for the UK, for instance. We could be the leaders in many of these things. We have the opportunity to do so. I put in a few other things, but given the time there, I think I'll just come towards my final slides then. There's some challenges here, and they're challenges to society and politics. Can we look beyond us here to the wider world? We're used to thinking of ourselves and our family, perhaps our region, perhaps our country, but can we look beyond that and think about us as members of planet Earth? Because this is a problem for planet Earth, and we will be part of that problem. Europe's had problems with migration, for instance. But you think what the problem will be when sea level's gone up a meter. Bangladesh is 5 degrees warmer. You imagine, are the people going to be able to live there? Where are they going to live? The migration around this world and the conflicts that will be developed. We have to just think about that. This wider world, we can't just call ourselves an island and it won't affect us. It will. And can we look on the long term? It's something about climate change. It's a long-term problem that is urgent, and that's very difficult for people and politicians to get involved with. I think it's easier now because most people are starting to hear about extremes closer to home. So the extreme weather has brought this up rather closer to people now than it used to be. I was going to give, yes, I will just say a little. As one talks about climate, okay, right, I will develop, I promise I'll stop at 8 o'clock then. So I was going to use an example here in the US then. If you take those who are very sincere in their Christian beliefs in the US, and there are some of them who say, God gave this planet to us to exploit the resources. And yet some of the others say, God gave this planet to us to act as stewards for it as we go forward. And as you're talking to groups, you find one polarized view there and the other from people whose religious beliefs you thought were rather similar. And you find this from around the world, that the reaction you get is actually determined a lot by such beliefs or such shared common heritage of those people. But the challenge then, can we find a shared vision and a belief in the equity? I said the UK target was saying by 2050, every citizen of this world could be expected to have the same requirement, same allocation of carbon dioxide. This is a sense of equity. We've used a lot more in the past, and the argument from China would be, well, you've used it in the past, it's our turn now. Whereas we say, well, we're used to using it and you're not. So the only real agreement will be some sense of equity, that we're all citizens of this planet and we can all share on this. So I come to my final slide then, that there's no doubt we're taking a huge gamble on the future of our planet and life on this planet. I think David Attenborough the other day put this in very strong terms, in terms of the extinction of many species and actually human civilizations being really threatened. And the planet Earth's solution to what we're doing to it is really to get rid of our species. And I think what we're trying to do is make sure that we can be part of the future of this planet. The world will keep going without us, but we want to be part of that. So as a climate scientist then, there's a challenge to me in all sorts of ways on this. The technologists, a huge challenge, but one that's amazingly stimulating to technology in universities, in companies, in countries. And this is the next industrial revolution we're going through. And it's one that will produce those new winners, and we want to be part of those winners. But the planet will be the major winner. So it's a challenge to our social, economic, and political ways of working, and I think you'll agree on that. So it will require imagination, determination, and leadership. It is both essential and it is possible. Thank you.
Thank you very much indeed for that.